Okay, so today we're going to work on the chain rule. This is going to be following up. We had started off with our differentiation shortcuts with the power rule, and then shortly thereafter we worked on the product rule video, and then we followed that up with the quotient rule video. And now here we are at the chain rule. So the chain rule is a really useful tool. So let's jump right in. So let's say we had some sort of a composite function where we had two functions, but the one function is going to be evaluated with another function as its input. So we're familiar with things like the function f of x, where x is going to be the input and then f of x gives us some sort of an output. So let's say instead of we have x, we had another function. So let's have it over here where x was equal to, say, g of, let's use some other variable, u. So x is equal to g of u. So we may want to have it where, let's cross this guy out so we don't get too confused over here. So x equals g of u. So it's easy for us to imagine that we could have f of x, because we didn't have to cross that out after all, sorry about that, which is going to be equal, because over here we have x equals g of u, which is going to be equal to f of g of u. So in this case we have it where g of u equals x, but g of u could equal some other more complicated thing like a polynomial or x squared or some other term. So this could come up a lot in mathematics, and a lot of the times anywhere that we could have an x, we could have something else like an x raised to a power or an x minus 2 or something else, and we have to be able to solve those problems and be able to differentiate. So what the chain rule tells us is if we wanted to solve for d, in this case we're using the independent variable u, du of f of g of u here, sorry about that, that's g of u, that would be equal to f prime evaluated at g of u multiplied by g prime of u. So this is a little bit confusing. There's the inside function, and then we're multiplying by the derivative of the inside function. It might be easiest just to take an example. So let's say we take something like the square root function. So we know with the power rule that if we had or let's actually have it where take something like x squared, and we want to find dx of x squared. So we know with the power rule that that'd be equal to, okay, we multiply by 2 because we take the 2 and we drop it down, and then we take it to the x, and then we take 2 minus 1 is 1, so it's 2x will be the derivative of that. Well, let's say we had it where we're going to take this whole thing and we're going to take the x squared, but we're having it minus 2, we're adding an extra term in there, and then we're taking the whole square root of that. So we don't really know how to evaluate this with a simple thing of just using the power rule or whatnot. We have to be able to break this down in a different way. So the inside function here is going to be that x squared minus 2 is the inside function. And the derivative of the inside function we know is going to be 2x because of the power rule. So it equals the dx of the inside. And then we know that the outside function is a square root function. And let's say that's the square root of, let's use u again to kind of denote this whole blob that's in there. And we know that the derivative of that function, it's basically u raised to the 1/2. We need to multiply by 1/2 out front, and then we subtract 1, so that's the negative 1/2, which is going to be equal to 1 over 2 square root of u. And that's going to be the derivative of the outside. Okay, so this is a, maybe not the most elegant way of putting everything, but hopefully it gets the point across. So let's take a look at this function. So we have the inside and the outside function, and we know the derivative of the inside, and we know what the derivative of the outside function is. So the derivative of the outside function, we're going to be taking inside, we have x squared minus 2, and we're going to be raising that to the 1/2 power, which is the same thing as having it in the denominator and taking the square root of it. So let's see, and then we're plugging it in with multiplied by the 1/2 out front because of the power rule. So there we go. So that looks a lot like this over here. We have 1 on top, the 2 up front. The square root of u is the same thing as, with these parentheses, this raised to the 1/2, and we know that we're using u to be equal to the whole inside function here. So the x squared minus 2 is this u term. We were just using this to express that kind of whole blob of what we're talking about here. We're going to have x equal to g of u, so that's what we did here. We need to multiply that by the derivative of the inside function, and we know that the derivative of the inside function is going to be 2x. So what we get when we cancel all of our terms and whatnot, or the 2's will cancel, we'll have x over x squared minus 2 raised to the 1/2 power. So you could also express this as x times x squared minus 2 raised to the negative 1/2. So, and there you go. So that's going to be the answer for this problem. We'll do a few more chain rule examples. This stuff is really important, especially as you get into multivariable differentiation. You actually have to be able to go through trees of kind of this thing, except it gets a lot more complicated. So it's really important to get the fundamentals down now, because it can get very hairy very quickly as you get into more complicated versions of this. As always, thanks for watching.